one remains as your row 2.
Okay.
So it's 2, 0, 4 in your row 1, 0, 1, minus 1 in your row 2. And then you take your row 1 and you divide it by 2 to get yourself a new row 1, because you want this to be a 1 in this top left.
Yeah.
So it ends up being 1, 0, 0, 1, 2, -1.
Yeah. Okay.
Now you've taken the test before. You know that you might have to show her, because it's a little bit odd, especially in B and C, to have to show steps. Like typically you just do the reduced row echelon form and your calculator write the answer and you have to know how to interpret the results.
Yeah. Okay.
But you know better. I'm just sort of hinting that I'm not sure.
Yeah. I think it's just like if you get the answer wrong and you have work, then you'll
That's
still
true.
get
Yes.
credit for it. So
Yes. Do you want us to go through B or C?
C, I was wondering if you do that on the calculator, like how you interpret the results for 3 variables.
Did you do you have the results, or do you want me to do that real quick?
I don't.
Okay, so I'm gonna go to something different than the calculator just for speed.
Yeah.
And it's the same thing here to give you the results here. -1, 3, and 4. Okay, so let me just snip this in. All right, so just to clarify what's going on here, you would make a matrix with 2 rows and 4 columns, and these just the A here represents the coefficients that you have. The answer here is the reduced row echelon form. Your calculator would give you the same thing on this. Okay, so what you have to almost like add to that this is X, this is Y, and this is Z. Okay, it's kind of a table, and then this is the right hand side. So the second row literally says 0x plus 0y plus 1z equals -5.
Okay.
And 0 times anything we don't care about, so z is -5. That's how you interpret that second row there.
Okay.
Is that clear?
Yeah. So, and then our X and Y, just 19 and -5.
Well, we're gonna do the same thing for row 1. So
Oh,
for
okay.
row 1, yeah, you're getting
Sorry.
a little bit ahead there. Row 1 is 1x. You're taking that 1 and multiplying by x, minus 1y plus 0z equals 19.
Yes.
So 0 times anything is 0. We don't care about that. And your answer here is that, okay, it's x minus y equals 19. This is where you have to go back to the way they want you to present the answers. Okay, so if the system is dependent, I'm reading that second sentence there.
Yeah.
Or third sentence, it says express your answer in terms of x, where y equals x. So they're saying that you need to solve this equation for y is the way to interpret that. So x minus y equals 19, add y to both sides, subtract 19 from both sides, x minus 19 equals y. So because there's 3 variables, it's that there's 3 answers that they're looking for. And normally it's x, y, and z, but in this case, your z is -5, your y is x minus 19, and x stays as x.
Yeah, that makes sense.
So when it says in terms of x, that means you have to have an x as part of your answer. If it said like in terms of another variable, then it would be that, but assume it's going to be this way. Do you want us to do the same thing for B?
I think that cleared it up.
Okay.
I think B, I understood it on the calculator, so
Got it.
I think.
So 5 is really similar. I'm not sure if you got to 5. 5 would be good for us to look at because it gives you the end result and you have to interpret.
Yeah, I was confused when I got to that one too then.
Okay. Fair enough here. All right, so number 5 here, we'll do one at a time. All right, so I'm snipping in part A. All right. So notice how the last row, and you tend to sort of focus on that last row. It's X, Y, and then it's the right-hand side. So that second row, I know maybe that seems backwards. Why would we go to row 2? It tells you the most information. So it says 0 times X, 0 times Y equals 1. And this is impossible. This is a scenario that just can't happen.
Mm-hmm.
Okay. And this is no solution.
Okay. Yes.
And it's because if you have nothing times X and nothing times Y, how can you get anything on the right-hand side?
Yeah.
So it doesn't matter what's in row 1. Row 2 tells you the information you need.
Okay.
All right, B is the other sort of exception here. Again, it'd be good to kind of label these as X, Y, and then the right-hand side. So row 2, this time it says 0 times X plus 0 times Y equals 0. And the thing that you're really looking for here is that it's an entire row of zeros.
Yeah.
This means infinite solutions. So notice the distinction. Row of zeros with a 1 at the end, all zeros. Very small difference, but one means no solution, one means infinite solutions.
Mm-hmm.
Okay, but there's a bit more to do.
Yeah.
We go to row 1 now. Row 1 says 1x plus 1y equals 2. Is it clear how I'm getting that from this table?
Yeah.
Great.
Yeah.
Now, the problem again says if the system is dependent, so infinite solutions means that it's dependent, express your answer as an ordered pair in terms of X. So that means your answer, like normally your answer is X comma Y, but they're saying only X,
Mm-hmm.
only X. So that means for Y, you have to solve for Y in this equation.
Yeah.
So
Okay.
Y would equal 2 minus X, and that's how you present your answer.
Okay. Thank you. That also makes sense now.
All right, so that's 5 now. Okay, 6 goes on to, we should probably do 6, just it maybe it'll solidify it if that's okay with you.
Yeah, that'll be perfect.
All right, so again, I'm going to put labels at the top, X, Y, Z, and then the right-hand side. All right, so hopefully by now, you know to start in the last row. The last row is 0x plus 0y plus 1z equals 0. So this means that z equals 0, and that's okay. It's okay. Not to be confused with 0, 0, 0, and then 1. That's bad, but this one just says z is 0. That's okay.
Yeah.
Row 2. Row 2 is 0x plus 1y plus 0z equals 2. Y is 2. So at some point you stop even writing the ones with 0, but might be good to do that for the test just to be solid here. 1x plus 0y plus 0z equals 3. X equals 3. So your final answer, you obviously X, Y, Z, but this time we have numbers, so you can go 3, 2, and 0.
Yes. Okay.
It might feel like this is a lot, but we've actually covered all the possibilities. This is the standard one, like where it works out. You get numbers for
Yeah.
X, Y, and Z. We covered the one where there is no solution, 0, 0, and 1. And then we covered the dependent case where there's infinite solutions. There's only 3 possibilities. And I've, said all that. I mean, it's, I know it's a test, it's stressful, but
Yeah.
if you bound your thinking to like, okay, there's only a couple of possibilities, you can do this. So let's go to the last row again, row 3. 0x plus 0y plus 0c is equals 1. Is this possible?
No.
No. So there's no way to get a number if you're multiplying everything by 0. So this is no solution. That's it. You're done at that point.
Thank you.
All right. So you said you tried, first few. Have you had any time to look at the next page, or where would you like us to kind of go? Excuse me, go from there.
Could we look at number 9?
Yes. So in typical math fashion here, to do number 9, you have to actually calculate the determinant of each matrix. So it's like it's a good question because it actually means that doing 7 and 8. Now, do you think you'll have to do these? I mean, are you allowed to use a calculator during the exam?
Yeah.
Okay.
Yes.
So, I mean, I would tell you to go right to the calculator and
Yeah.
calculate
I did.
the determinant of that. Do you remember how to do that, or do you need me to show you on the?
I think I got it. I did do number 7 already.
Okay. So give me the determinant of each of those for 7.
7a was 4, 7b is 0, and 7c is -4.
Okay.
And those are all I checked, so they're actually right.
Good. So if the determinant equals 0, there is no inverse. Like you're
Okay.
guaranteed to see something like that on the test. Maybe one that does not have an inverse, one that does.
Mhm.
Now so that's why it says if it exists, because the person who wrote this knows that there's one that does not exist. For the ones that do exist, you just go and calculate it on the using the built-in function there. You will not be asked to do a 3x3 by hand. Like maybe
Yeah.
A you could do by hand, show your work, but definitely not C. So to do this, you got to enter this in and just calculate the inverse. That's that X to the -1 button on your calculator. You may need to use math enter to convert it to a fraction.
Okay.
Always make sure you've entered it correctly, especially if your answer doesn't line up with what you see on the test there.
So on the calculator to solve for the inverse, you just put in the why am I
So let's say you've entered.
Yeah, sorry.
Let's say you've entered this in as A. Okay, you got to go grab the matrix, and I think it's under second matrix, something like that. But you get the A, and then you use that -1 X to the -1 power.
Okay.
There, and I'm happy to show you that here if you need me to.
I think I found it now. I was just
okay.
Yeah. Thank you.
So does that satisfy kind of what you were looking for on number 9, or do you want us to do any of them specifically?
No, I think that's good. Thank you.
Okay. All right. 10's a good problem because you can't use your calculator. Like this is the kind of question I would ask on a test, because you can't just put it in the calculator and get the answer.
Yeah.
Requires a little more work here, but whether you actually have that, I don't know. Okay. So to do 10, you always calculate the determinant first. Okay. But this one you have to do by hand. So you have to know that it's 5 times -6 for the determinant minus, and then you go the other direction, 10 times -2. So you'll sometimes see students drawing lines, in there.
Yeah.
However you want to remember that. Your signs are very important. It's always subtracting. If this on the right is negative, well, then you're adding. So this becomes plus 20. So if you want this to not have an inverse, this would equal 0.
Yeah.
So you solve for x here, you get x equals 4, but that means it means it has no inverse. So for any other value, basically anything but 4, you're good.
Yeah.
And somehow that would be represented on your test. It might be like -infinity 4 union 4 infinity.
Yeah.
Could be set notation. Lots of possibilities. I have no idea what they will.
Yeah.
All right, for part B, it's the same thing. It's just more complicated.
Yes, I think I can do that on my own.
Great.
Or I know I can.
All right. Okay, where should we go from here?
Can we look at 11C?
Yes. This is classic exam question because they're missing a letter in each row.
Yeah.
So you might even want to write it as -x 1x plus 1y plus 0z equals -1, 0x plus 1y minus 1z equals 6, 1x plus 0y plus 1z equals -1.
Yeah.
Now it looks better.
Yeah.
So your matrix A is the coefficients of x, y, and z. It's so easy to just forget one, put it in the wrong order.
Yeah.
And then typically this right-hand side is called B. It's -1, 6, -1. All right, so to solve this using matrix inversion method, you do have to find the inverse of A. And you want to show that, like if you're trying to show your work, you can use your calculator, just show the output each time. Like say, okay, A inverse, here's my actual inverse. I'm going to spend a moment actually calculating that. If you don't mind here, -1, 1, 0.
Yes.
All right, so this one does have some fractions. If you get fractions that don't, or decimals that don't turn into fractions, that's probably an indicator you made an error entering it. If you have time, it's always good to do it twice. So your solution to finding x, y, and z, after you find the inverse, and this is how you show your work, x, y, and z, is A inverse times B. So you can show that, well, I'm going to copy and paste here. You can show that by grabbing the inverse, and then you multiply by those numbers on the right-hand side, -1, 6, and -1.
Yeah.
And then you get your answer, whatever that is.
Which you can just do that in the calculator.
Yes. But this is how you show the work to kind of convince them, and that's what they're looking for. I mean, if I were grading something like this, I want to see these steps, and maybe the most important thing though is to get the right answer. Like even if it says to use matrix inverse, I would still use reduced row echelon form, RREF, and make sure I got my answer, and then make sure it's the same. Make sure it's consistent each time.
Yeah. And then number 12 is kind of like going off that, and I don't think there'd be a question like this on the exam, but I don't really know how you would approach it.
Yeah, good question. This, yeah, probably won't get this, but you might get like I don't want to say this. The only correct answer is C inverse D. This is the correct one. It has to be in this order. Like we're used to multiplication ordering not mattering, but in matrices it does matter.
Yeah. Oh, because it's like the A inverse B.
Yeah. Yes.
Okay.
Exactly. Now, like the way they might present this to you is they might give you the inverse and they might put it in the wrong place. But just you got to know this. You have to absolutely know that and be able to, piece it together with given information, I guess.
Yeah.
These other ones are not that like, but here, okay, to be clear here, these work like in terms of like you can do these calculations, they just don't give you the X that you're looking at.
Yeah. Okay. Thank you. That was kind of what I got to when I was doing it by myself.
Okay.
So I haven't looked at the starting at number 13.
Okay. Do you want us to do them in order or?
Yeah.
Okay.
Yeah, I'm sorry. I was trying to be more prepared, but
That's
I just
okay.
got like a horrible migraine today and it's
I
kind of
am,
bedridden.
there's no judgment here. You're a college student, you have a lot going on and you're doing the best you can. All
Thank
right.
you.
So using Kramer's rule, do you get a reference sheet? Do you get
No,
you don't get it. You don't, and you can't bring anything to class?
no.
All right. So this is one of those like where it's like I'll show you Kramer's rule, but if you're not showing your work, like I don't know why. I mean, they can't demand that you use this. Okay.
Yeah.
But we'll get to that. So let's go back to they say use 11. So we'll go to 11A first. 3, 6, 3, 2, -1, and 7. Okay. So they're the Kramer's rule here. I don't want to say this. So the first thing you want to find is what's called, they usually refer to it as D, and it's the determinant of the coefficient matrix here. So it's the determinant of 3, 6, 2, and -1. Okay. Is that okay?
Yeah.
So you can get that number here. I'll get it for us in a moment. I just need to get a reference here. Okay, the next one you're going to calculate is dx. Okay, so what's called dx, and dx is taking the right hand side, so this 3, 7, and replacing it where the 3 and the 2 are. So there's some similarities to this first one. It's the 6 and the -1, but the right hand side replaces the x column here.
Yeah.
And so these are numbers. We're going to get these numbers here. The last thing you need is what's called dy, which is the determinant of, and you take this right hand side and replace it where the y values go. So it's 3, 2, those are the x values, and then 3, 7 in the y values. So you have to get these three numbers.
Yes.
And I'll get those. So this one is -3 -12 -15 -1 -42. No, -3 -42. So -45. 21 minus 6 is 15. Okay, so x, this is the Kramer's rule, dx over d, which is -45 over -15, which is 3. Y is dy over d, which is 15 over minus 15, which is minus 1. I'll just say this again, like you can just solve this using any method you want, but my guess is what they'll have you do is like calculate like the numerator or of one of these, and that's how they will ask you
Yeah.
this question. So they won't like, because they know you can just put this in your calculator. They're going to want something else there. The hardest part is to remember that the right hand side is what fills in the x and the y for dx and dy.
Yeah.
It's just it's a little awkward to remember that.
Yeah.
So it's the same thing for the others. We could do if you want, we can do B or C. Up to you. I would recommend we move on. Make sure we get through all the
Yeah.
problems here.
I did also make an appointment for tomorrow because I thought it would take
Oh,
a lot of time.
well, we can take more
But-
time here. I hadn't even looked ahead to tomorrow.
Yeah.
You tell
I
me.
guess
What would you
if
like to
we do
do?
have times, if we could look at C.
Let's do C right now. Let's now that it's current here. Okay, so we previously rewrote this as I don't want to say this as with the letters, but we're just going to need the numbers. So -1, 1, 0, and -1. Okay, and then 0, 1, -1, 6, 1, 0, 1, -1. So this is the augmented matrix. It's everything. You don't need to know that, but it's everything. The first thing you need is D. D comes from the coefficient matrix. So it's the determinant of the first, everything but the right hand side, the determinant. So -1, 1, 0, 0, 1, -1, 1, 0, 1, like that. And that's a number. Some sort of number there. We'll get that in a moment. dx is where you take the right hand side, this right hand side here, and substitute it in for x. But again, you're finding the determinant, -1, 6, -1. So when I'm rewriting them, I'm looking at the top one to see what's the same. I'm trying not to go back and forth because that's pretty tough here. For dy, you take the right hand side and plop it right there in the middle for y.
Yes.
So notice you're only changing one column at a time. The last one you need is dz. dz is the determinant of, so you're keeping the first two columns and then substituting it for the last, like that. All right, so we need to actually calculate each of these. This is the time-consuming part here.
Yeah, but was there a way to do that on the calculator?
You can do the determinant on the calculator, but you have to enter each of these separately. There's not really a shortcut for this. There is, but I mean, it's kind of beyond the scope of this class to like try to figure that out. But for the that first one, it's -2. Let's see here. You've got some solutions here. They don't actually give you the determinants, do they? They do not. Okay. All right, keep going here. It's also -2. That's not right. Sorry, that's not right. Let me,
No, no, you're good.
boy, I don't like what I just did there. This ends up equaling -6. -4. This one's 8. Okay, they all worked out nicely, which kind of expected. X is dx over d. -6 over -2. So that ends up being 3. Y is dy over d. -4 over -2. Last one, z is dz over d. 8 over -2, which is -4. I again would solve it using reduced row echelon form first, making sure it's 3, 2, and -4, and that all my answers lined up along the way.
Okay, thank you.
Yeah. Were we working on this before spring break? It seems kind of somewhat familiar.
Yeah, yeah, we were.
Okay, so this you've been doing this for a while here, so maybe it because it's a lot of it's calculator. Hopefully, there's transference to the exam, good scores.
Yeah.
All right, so I would recommend we set up 14. Setting up a story problem is kind of the most difficult part. The solving you got many options for that. Was that okay?
Yeah.
All right, so let's go to number 14 here. You manage an ice cream factory that makes 2 flavors. Okay, vanilla and kind of. All right, first, actually, I'm doing this wrong. You always go to the last sentence here. That tells you the variables. The variables are here, the quarts of each flavor, the quarts of vanilla, quarts of mocha. Okay. So you can use X and Y. Do you typically use X and Y, or do you try to like match them to like V and M for vanilla and mocha?
No, X and Y.
X and Y. Okay. All right. So into each quart of cream of vanilla goes 2 eggs and 3 cups of cream. So there's depending on how you want to look at it, there's an eggs equation and there's a cream equation here. So for it's 2x and 3x for the vanilla. And then mocha, 1 egg, so 1y, and 3 cups cream, 3y, like that. And then you typically have totals. So you're really setting up a table.
Yeah.
You probably saw this in previous class. You have in stock 550 eggs, 1050 cups of cream. So you once you set up your system, you can solve it any number of ways. Okay, I would always just go to RREF in this case. But any questions on setting it up here?
No, we've done this every lesson of this chapter. I mean, of this class, the same question.
Really?
Yeah.
Well, that's awful. All right, let me so I was going to check one thing here. So when you set it up correctly, it works out nice. I was going to check here. If you set it up wrong, meaning like you put these things in the wrong place, it it may not work out. So that's also maybe an indicator of whether you've done it right or wrong, is do you get nice answers here when you
Yeah.
look this up. Now, we don't need to use Kramer's rule unless you want to for this. I can't believe we're using this problem over and over again.
Yeah.
But whatever, that's the way it goes.
Um,
Do you want us to do Kramer's rule on this?
yeah,
Great.
just because I guess if they're gonna ask it again, they probably will want it that certain way.
You are the customer. I am only asking because I want to make sure you get what you need here out of this. Okay, so it's there's always the first thing is this D. The D is the coefficient matrix. It's the 2, 1, 3, 3.
Yeah.
Okay, and because this is 2 by 2, we can do it quickly by hand, or you can go to the calculator. 2 times 3 is 6. 3 times 1 is 3. 6 minus 3 is 3. Okay. The dx, that's the harder one. That's the one that's more difficult. You take the right-hand side and put it in the x column.
Yes. So
550, 1050, 13. Okay, now the numbers get larger, but it's the same thing. 3 times 550, that's 1650 minus 1050. That is 600. And I wait till the end. Like I don't try to jump to, okay, x is dx over d. Just keep going here. So for y, you take the right hand side and you put it in for y. Replace y. Is it at all interesting that this works out? Like that you can just sort of move these numbers around and they work?
yeah,
Like
it's just I'm usually like find math very easy, but I think this class is harder because I don't necessarily understand like why
yeah,
it works.
it's a bit of magic here. It's like, why does this even work? So 450 for that. So x is dx over d. You will want to remember this formula for that. So that's 600 over, what did I write, 3. Y is dy over d, which is 150.
Okay. Okay, that is actually getting much easier. Thank you.
Awesome. I like hearing that.
Let's get into the easy parts.
Better than you saying, I don't think I'll ever be able to figure this out. All right, should we keep going here? We could probably get time for like one more question or two. We'll see.
Yeah, if we have time for one more.
15, yeah, let's do 15.
Okay. Thank you.
This looks like a WebAssign question. S is the set of Arthur. Okay, all these different people whose names we don't use very often, at least. Let's go down to this. The notation here could be something you've not seen in a while. There's two things going on. A union C is a set. Like it's literally a set. It's either A or C, could be in one or the other or both. But this N, very importantly, this N means just to count them. Like you don't have to actually give the set. You can just sit there and count. There's 1, 2, 3, 4 in A. Franz is already in A, so you don't count Franz, you don't double count, but Tina's new. That's 5. So the answer to this is 5. Okay. But if you actually wanted A union C, which is a set, it's D, F, J, S, and T. The N means to count however many elements, but you never double count.
Yes. Okay.
All right, so let's look at the next one here. I'm going to re-snip in the set. All right, so A intersect B naught. So you want to do this in pieces. We first want to figure out what is B naught. So what is basically what is not in B. Okay.
Yeah.
And it's like you actually need to go back to the original. Let's go back to the original, grab that for S. Okay, so you look at this original here. That was bad. Right there. Okay. So you basically cross out the ones that are in there in both of them. Sorry, I'm not saying the names.
No, it's
So B naught is A, D, and J. Basically anything that's not in that list.
yeah.
Intersection, this upside down U means intersection. It means both. They have to both be true.
Mm-hmm.
Okay, so if we look at A, what does A have that's in B naught? It has, it looks like D is in both and J is in both. So I'm looking at the overlap here of this one with D and then J and J. Is that okay? Is that okay?
Yeah.
And then we finally count. Now we finally count the number in A intersect B naught, which is 2.
Okay. Yeah.
Please, 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 make the sets and then count them at the end.
Mhm.
All right. Well, we will be stopping right here for today.
Perfect.